Welcome back to Iron Process, your journey to discover the most impressive manufacturing processes from around the world. In today's episode, we step into the world of the maritime industry, a place where colossal vessels are constructed, restored, and maintained with staggering precision. From modern mega yachts to the massive transport machines of the deep sea, we will reveal how humanity transforms raw materials into true engineering marvels. Let's get started. This footage captures the restoration and rebirth of the Cassiopeia, a classic sailing yacht. The shipwrights begin by using hammers and chisels to dismantle the decayed wooden planks from the hull. Afterward, massive timber logs are measured and shaped using chainsaws and specialized rip saws to produce raw planks precisely sized for specific locations on the ship's ribs. This stage is deeply traditional and perhaps the most unique part of the process. Instead of using mechanical presses to force a curve, the thick wooden planks are placed onto a custom-built steaming system, a fire-heated trough combined with a water reservoir. The steam softens the wood fibers, making them pliable and flexible enough to bend to the complex curvature of the hull. While the wood is still hot and supple, the shipwrights must work with extreme speed. They hoist the planks onto the hull using wooden wedges, sledgehammers, and even their own body weight to force the curve board flush against the frame. Fasteners are then driven in to lock the shape permanently before the wood cools and hardens. Heat. To ensure the vessel is completely watertight, the shipwrights perform the caulking stage within intense meticulousness. Using specialized caulking irons and small wooden mallets, they tightly pack open into every tiny seam between the planks. This is an ancient waterproofing technique that demands patience and a perfectly consistent striking force. Finally, the ship is entirely encased in its new hull planking. This is how a maritime legacy is preserved, allowing it to continue its journey across the open ocean. The global cruise industry is under immense pressure regarding carbon emissions, and the construction of the Ada Nova at the Meerwerf shipyard in Germany is the definitive groundbreaking answer. This is the world's first mega cruise ship to completely abandon traditional diesel fuel in favor of liquefied natural gas, LNG, drastically reducing toxic emissions into the ocean. Inside the covered building dock, the cruise ship takes shape through modular assembly. Dozens of steel blocks weighing hundreds of tons each are maneuvered by gantry cranes and welded together in a synchronized rhythm. Once the bow section is largely complete, workers begin painting the vibrant eye and red lip motifs, the unmistakable brand identity of the AIDA Cruises fleet. Construction takes place simultaneously across multiple levels. Prefabricated cabin modules fully fitted with interiors are carefully slid into the hull. Beneath the ship, the Azipod propulsion system is transported via SPMT and precisely fitted into position. The polished alloy propeller blades are manually installed, locking the megaship's propulsion system into place. The float-out ceremony is a grand spectacle. As the dry dock gates open, the Idan Nova, measuring 337 m long with a gross tonnage of over 183,000 tons, touches the water for the first time. Assisted by tugboats, this massive architectural feat slowly slides out of the construction hall before thousands of spectators. This is more than just a vessel sporting a friendly, smiling lips design. It is a synthesis of industrial precision, aerodynamic engineering, and pioneering energy technology, setting a new sustainable benchmark for the entire global commercial shipbuilding industry. From the moment it left the dry dock, the AIDA Nova became more than just a newly launched ship. It marked a turning point for the cruise industry, where precision engineering, modern design, and clean energy converged to open a new sustainable standard for the future of maritime travel. Today, modern shipbuilding has moved away from traditional bottom-up construction. Instead, they utilize the mega block method to significantly save on both time and costs. Rather than assembling dozens of small sections inside a dry dock, the ship is divided into several colossal segments, typically 2 or 3 massive horizontal sections. Each part weighing thousands of tons is constructed independently on the ground. This approach makes installing piping and electrical wiring much easier and safer than working within the cramped confines of a nearly finished hull. The greatest challenge lies, as in transportation and alignment. SPMTs are used to maneuver these massive steel blocks into the dock. Once there, the sections are fitted together and welded with near absolute precision, ensuring structural integrity for operation in the open ocean. Look. Looking at the raw, rusted hull in its early stages, it's hard to imagine it will eventually become a luxury cruise ship. But this is no miracle. It is the result of thousands of hours of meticulous labor, transforming lifeless steel plates into a true mechanical marvel of the seas. This footage captures the complete 3-year journey of the mega cruise ship MSC Meraviglia, from initial technical blueprints to final completion at the renowned STX France shipyard. The project launched in March 2014, involving over 1 million design hours and 23,000 technical drawings. In April 2015, the first steel cutting was performed using laser technology, officially transforming the Vista project and design into physical structures on the shipyard floor. The fabrication process begins with raw steel plates. CNC and plasma cutting systems shape the material with high precision, preparing for the most critical phase, modular assembly. Instead of building the entire ship in one piece, it is divided into dozens of massive blocks. Each block is manufactured independently, pre-fitted with structural elements and even internal systems. They are then hoisted into position and joined using heavy lift equipment and laser alignment sensors. This represents a revolutionary shift from manual craftsmanship to full-scale industrialization. Consequently, shipbuilding time is drastically reduced while precision is significantly increased. Parallel to the structural work is the integration of technical systems, engines, navigation, electronics, and drag reduction technologies. Everything is integrated as a complete ecosystem where every component must function in perfect synchronization. By August 2016, 300,000 L of specialized marine paint were applied across the hull's massive surface area, including the distinctive crimson antifolding layer for the submerged sections. Furthermore, the paint surface is optimized for maximum smoothness, allowing water to flow past the hull with minimal resistance. Even a minor improvement in friction can yield massive efficiency gains during continuous long-haul voyages. In September 2016, the dry dock valves were opened, and millions of gallons of seawater surged in. The MSC Meraviglia floated for the first time, supported by Archimedes' principle. A fleet of tugboats immediately moved in, skillfully towing the massive unpowered steel giant out of the narrow dock and over to the outfitting quay. Inside the ship is currently a chaotic, massive construction site. To meet the deadline, STX France utilized an industrialized solution. 2,244 cabins were prefabricated on shore, complete with furniture, plumbing, and electricity. These modules were then trucked to the pier and slid into the ship's open bays, using specialized cranes at a record pace of 2 cabins per hour. Simultaneously, the mega amenities took shape. The 80M LED dome, a 985-seat Broadway-style theater, and a complex 360 degrees rotating mechanical stage designed exclusively for Surf du Sol. In March and April, 2017, the ship underwent sea trials. Engineers closely monitored data from the cluster of 4 Wärtsilä V12 engines, the stabilizer fins, and the massive windlass systems which were free dropped to measure pulling tension. The specialist team also conducted acoustic and vibration scans across all decks. Once every parameter met the standards, final luxury details like the S. Swarovski crystal staircases were completed. On June 3, 2017, the MSC Meraviglia was officially christened and set sail on her maiden voyage to worldwide acclaim. This cruise ship is truly magnificent. I wish I could experience it for myself just once. No matter how modern its construction, a ship cannot operate reliably without proper maintenance on the open ocean. Every component is under constant assault from salt, waves, and time. For vessels like the Federal LB, periodic maintenance follows a strictly orchestrated schedule. This is the most grueling stage of the labor. After months at sea, the hull is encrusted with algae, barnacles, and thick layers of rust. Workers utilize ultra-eye water jets and sandblasting techniques to strip away the old paint. Dust and sparks fly everywhere, creating an atmosphere of intense, high-stakes industrial grit. Once the steel surface is stripped to a clean shine, the painting process must begin immediately to prevent flash oxidation. Specialized man lifts hoist painters high into the air to apply the heavy-duty primer. The signature crimson hue of the submerged hull gradually begins to emerge. The ship undergoes a total transformation. The vessel's name is repainted with razor-sharp precision. Mechanical components, including the propeller and rudder, are inspected and technically calibrated. What was once a rusted mass of iron now looks as if it just rolled off the assembly line, ready for its next voyage. The workflow at MTG Dolphin never pauses. As soon as one vessel is completed, its sister ship, the Federal Warrior, arrives to begin the exact same process. Massive gantry cranes operate at full capacity, maneuvering equipment blocks weighing several tons onto the deck. At this stage, meticulousness is the top priority. Workers inspect every weld, reinstall cabling systems, and test the cargo hatch covers. Aerial footage reveals the sheer scale of the vessel as it dominates the shipyard's footprint. The video concludes with images of the overhauled RP pools, leaving the dock and cutting through the waves. The vibrant red paint glowing under the sun stands as a testament to the labor of hundreds of shipyard workers. This maintenance cycle doesn't just extend the ship's lifespan, it ensures the safety of the crew and cargo on their transoceanic journeys. While massive steel ships represent power and scale, the aluminum catamaran introduces a completely different direction: lighter, faster, and more efficient. The material of choice is aluminum, lighter than steel, yet durable enough to withstand the structural loads of the marine environment. The aluminum plates are precision cut using CNC and laser technology, then joined via TIG welding. Unlike steel, aluminum is far more temperamental, and errors are nearly impossible to rectify easily once the metal has been heated. The two hulls are constructed independently and then joined by massive crossbeams. This is the most critical stage of the assembly, as it determines the structural rigidity and load distribution of the entire craft. Once the hull is complete, the technical systems from engines, electrical, and plumbing to the interior outfitting are installed with a primary focus on weight optimization. Every detail is scrutinized, a little lighter, a little more efficient. The final stage is the sea trials. The vessel is tested for stability, maneuverability, and speed performance. It doesn't just need to function, it must outperform its original design specifications. The aluminum catamaran demonstrates a vital point. Maritime engineering isn't just about building bigger ships, it's about building smarter ones. It is this optimization-driven mindset, when combined with massive scale, that forms the foundation for the most complex systems on the ocean, where every detail, no matter how small, affects the performance of the entire machine. If a ship is a complex system, then offshore, humanity constructs even larger structures and operates them under far more extreme conditions. The Montrose BLP project is a prime example. These colossal modules are fabricated onshore with high precision, then transported to sea by specialized vessels and installed using ultra-heavy lift cranes. It is a process where every maneuver must be meticulously calculated as the surrounding environment, waves, wind, and currents, is in constant flux. The greatest challenge is not just lifting and placing structures weighing thousands of tons, but connecting them perfectly. The modules must align with near absolute precision while integrating with existing systems to create a seamless, continuous operation. Once completed, the entire structure functions as an offshore factory, a processing operating and maintaining itself for long periods without direct support from land. This requires every system to achieve an extremely high level of reliability. This project represents a major step forward. Maritime engineering is no longer limited to shipbuilding, but has expanded into large-scale offshore industrial systems. It is precisely this experience in modularity, precision assembly, and operation in harsh environments that has become the foundation for humanity to create the most complex machines on the ocean. We have just completed a comprehensive journey from the world's most advanced shipyards to traditional artisanal restoration workshops. From clean energy mega cruisers to colossal oil tankers, and through every stage of construction, assembly, maintenance, and the rebirth of these massive maritime machines. Through all these perspectives, it is clear that today's maritime industry is no longer merely about building a ship. It has evolved into an incredibly complex engineering ecosystem, a convergence of high technology, sophisticated production management, and modern engineering logic. The most distinct shift is the transition from traditional craftsmanship to large-scale industrialization. This shift does not only shorten construction timelines, but also enhances quality, safety, and the ability to integrate intricate internal systems. Beyond construction, the work of maintenance and retrofitting reveals an equally vital dimension, from cleaning, coating, and structural repair to the complete conversion of a vessel's function. Every process demands precision, coordination, and high-level expertise. This proves that a ship is not a static product, but a dynamic system that is constantly updated, improved, and adapted over time. From all of this, we can affirm that the modern maritime industry is entering a new era, one where massive scale, absolute precision, and sustainable thinking walk hand in hand. Every ship is more than just a means of transport. It is the culmination of millions of labor hours, technical ingenuity, and the ambition to conquer the ocean. And from these shipyards, dry docks, and silent maintenance journeys, a new benchmark is being forged. A standard for an industry that never stops innovating, never stops perfecting, and is always looking toward a sustainable future on the vast ocean. Thank you for listening to the end of our story. If you enjoy videos like this, please hit like, share, and subscribe to the channel so you don't miss our upcoming stories. Iron Process says goodbye, and we'll see you next time.